and we'll do a swift, smooth changeover as we now welcome to the call Janet Hart, Leea, Sarvela, and Henning Anderson. Welcome, welcome, welcome. How are you doing?
We're doing great. Well? It's a little bit Fantastic. Gray in Boston, but we're doing good.
Good, good. I'm really kind of getting confused. I wanted to say to you that how are you doing this evening, because it's evening here, but you know, it's International Microorganism Day. We're talking to people all over the world. You know, you can't say that. So yeah, good to know where you are. And yeah, without further ado, I think I'll let you get started straight away so we can get hearing about what you're talking about. So Janet, I think you're going to start. Is that right?
Yes.
Yes. And so you're a professor of biology at Massachusetts College of Pharmacy and Health Science. Is that correct? Yeah, it is. It is. But it's a pleasure to have you here. And yeah, I'll hand the floor over to you straight away.
Great. Thank you so much. Let me just kind of organize my tiny little desktop here. Yeah, happy to be with all of you today. We're here in Boston again, as I mentioned, a little bit of a gray evening. So good morning, good afternoon, and good evening, no matter where you are. So as was mentioned, I'm a biology professor here in Boston in the United States. I thought I would disclose I'm not associated with any industry or governmental institutions. I'm here solely as an educator and a mom, and together with my students, we really hope to help people understand the science around microbes and vaccines, and that's what our talk is all about. And we also hope if you have some questions, we'll do our best towards the end to answer them. All righty, so let's get started. So microbes are everywhere. You may have heard that in other talks for International Microorganism Day. Some are harmful, but most are actually quite helpful. In one drop of surface seawater, there's about 10 million viruses. Fortunately, very few actually make large animals like fish or humans sick. Almost all of those viruses actually attack marine bacteria. Viruses, of course, unfortunately, can also infect other animals, birds, reptiles, insects, and of course, us. Viruses have probably existed for millions and millions of years, evolving with other life forms, and that's millions and millions of years of developing and adapting and getting better at what they do. And for the microbes that are the bad guys, unfortunately, that's making us sick. So this talk is focused around stories. Of course, stories are really important for us as human beings, no matter what culture we come from. So I wanted to start by sharing this important story from not so long ago. This gentleman, Morton Chapman, he writes, "I can remember no experience more horrifying than watching by the bedside of my 5-year-old stricken with polio. The disease attacked his right leg, and we watched helplessly as his limbs steadily weakened. On the 3rd day, the doctor told us that he would survive and that paralysis was the worst he would suffer. I was grateful, although I continued to agonize about whether my wife and unborn child would be affected. What a blessing that no other parent will have to endure the terror that my wife and I and thousands of others shared that August." So we've been working very hard to eliminate polio from the planet, which we can do since it only infects human beings and doesn't hang out in any other animals. The only pathogen we have ever gotten rid of in the wild globally has been smallpox, and that's because it also only infects human beings. And vaccines were key to making sure that that would happen. In fact, we've seen incredible reductions in illness and death in the 20th century for many diseases, and that's because of vaccines. You can see here on the left a bunch of different diseases. This is just a small sample. You can see, right, that we were able to, again, bring down smallpox as well as diphtheria compared with the 20th century levels of disease to 0 in the 21st century. We also dramatically decreased in the United States the amount of paralytic polio, measles, mumps, and rubella, as well as congenital rubella, which causes birth defects. But when diseases become less frequent due to high vaccination rates, we can become a bit complacent and we forget just about the impact of these diseases. And that's why certain kinds of infections like pertussis can come back. And we've seen this in the US, like is shown here. So stories and scientific evidence are really very, very important in helping people make informed decisions to protect their health. So here are a bunch of vaccine-preventable diseases. Some of these are viruses and some are bacteria. And I'm so grateful that I've had access to vaccines that I could protect my kids from all of these different kinds of diseases. I didn't have to worry about my kids getting a lot of these. My son didn't lose his hearing after getting a mumps infection. I can protect both my son and my daughter from deadly cancer and meningitis. And my kids are much less likely to develop the painful condition called shingles later in life because they've been vaccinated against chickenpox. So I'm not just protecting my kids though. The great thing about vaccines is that it protects their friends, teachers, and everyone else around them. I wanted to point out a couple of these vaccines, starting with rabies. If you get infected with rabies, you will die. 100%. It's got a 100% mortality rate, which is very scary. And rabies does exist in many, many parts of the world. And every year people do die from rabies. But this vaccine, the rabies vaccine, is pretty amazing because it's one of the rare situations where a vaccine can actually be given after you're infected. And so it saved many, many lives. Hepatitis B is so common, we think upwards of a third of the population of the planet is infected with this type of virus that attacks your liver and can cause liver failure and cancer. So a hepatitis B vaccine has been amazing in really preventing that kind of outcome. Rotavirus is so contagious that every single child on the planet eventually gets infected with it unless they are vaccinated. And it's the third leading cause of infant death worldwide due to diarrhea. So I wanted to step back a little bit in time and share the fact that immunization actually is a concept with a pretty long history. The top picture that you can see in the top right of your screen is from Mexico in the 1500s, and it very sadly shows the devastating effect of smallpox on the native population. The picture down in the lower right corner is Fulin, the Shunzi emperor in 17th century China. Unfortunately, he died of smallpox, but when his son became emperor, his son actually survived smallpox as a child, and his son then became a big champion for supporting inoculation in the population. Between 1910 and 1940s, we had some pretty incredible advances in really fighting a lot of major pathogens, major diseases that were causing a lot of death and a lot of illness. We were able to develop vaccines against tuberculosis, yellow fever, diphtheria, tetanus, pertussis, influenza. Between 1970 and 1990, we had a lot of victories. We were able to, in the United States, get rid of polio completely. We were able to eradicate smallpox, as I mentioned, from the entire globe, except for a few laboratories. But it's no longer in the wild. I'm old enough that I was vaccinated against smallpox, but most people today don't need to be because we got rid of it. We also had some problems though. We had some adverse events. There was an earlier, it's not the same rotavirus vaccine that's being used now, but there was an earlier version that caused a rare but very serious side effect in infants. We'll talk a little bit more about risks versus benefits of vaccines a little bit later. We also had some setbacks. We had some major resurgence of measles in the US and in Europe and a few other places around the world. We had a little bit more recently, we've had some failures of vaccines. There were some HIV vaccines that showed some promise early on that ended up not being able to work properly to help protect people against HIV, and that was obviously very disappointing. We've also seen massive improvements in the way that we deliver vaccines and make safety and efficacy a really top priority. And then I also wanted to talk about a really important topic, and that's equity. Measles is no longer a common disease in the United States, but globally, it's still a major cause of death of children under 5. And that's highlighted by this slide from data from the WHO, the World Health Organization, that shows just how something that really should be eliminated through vaccination has not been because of access. We have not been able to get the measles vaccine to enough parts of the world to really bring down this rate of disease and death in children and adults. So I wanted to share just a little highlight from the report that this is taken from. This is from 2019, not so long ago. And the report states, measles outbreaks continue to spread rapidly around the world, with millions of people globally at risk of the disease. In the first 6 months of 2019, reported measles cases were the highest they have been in any year since 2006, with outbreaks straining healthcare systems and leading to serious illness, disability, and death in many parts of the world. The Democratic Republic of Congo, Madagascar, and Ukraine reported the highest numbers of cases. However, cases dramatically decreased in Madagascar as a result of a nationwide emergency measles vaccination campaign, highlighting how effective vaccination is in ending outbreaks and protecting health. The largest outbreaks were in countries with low measles vaccination coverage, which left large numbers of people vulnerable to the disease. At the same time, protracted outbreaks are occurring even in countries with high national vaccination rates. This results from inequities in vaccine coverage, gaps and disparities between communities, geographic areas, and among age groups. When enough people who are not immune are exposed to measles, it can very quickly spread. The United States reported its highest measles case count in 25 years, and in the WHO European region, there were 90,000 cases reported for the first 6 months of 2019. The reasons for people not being vaccinated vary significantly between communities and countries, including lack of access to quality healthcare or vaccination services, conflict and displacement, misinformation about vaccines, or low awareness about the need to vaccinate. In a number of countries, measles is spreading among older children, youth, and adults who have missed out on vaccination in the past. So I personally have been very fortunate to travel the world in my life, and health equity is something that I care very deeply about, as I know many of my colleagues do. And so I wanted to share a little bit of one of my own stories. Here I am a long time ago with fewer gray hairs, with my little baby girl. Isn't she cute? And she spent the first 5 years of her life being a little Parisian girl, eating croissant and running around beautiful places like this. Being a mom, I have a smile on my face in this picture, but trust me, I was exhausted trying to keep up with her. And I remember her getting her vaccines, but there was one, the pneumococcal vaccine, we somehow forgot. And I honestly don't remember why. Fast forward to age 5, and after a really bad prolonged cold, she ended up very seriously ill. And in this hospital, the picture on the upper right of the screen, she was sick from, you guessed it, Streptococcus pneumoniae, which is the bacteria that causes pneumonia and meningitis, and was the pathogen that the vaccine she missed should have protected her against. It was honestly very scary to see her hooked up to IVs and very sick. But fortunately, there was a happy ending to this story. Here she is with her little brother not so long ago. So let's talk a little bit more about vaccines, the different types of vaccines that are out there, and maybe dispel a few myths. All right, so the idea behind vaccines is to fake out your immune system. Give it something that looks like the bad guy to react to and build up some protection against. Infections are always a race between your immune system and the nasty pathogens, and pathogens, unfortunately, often win that race. So vaccines give us a really crucial head start in that race. So one of the older kinds of technology we use for vaccination is something called a live or attenuated vaccine. These are very effective, but they often have a little bit of a trade-off because there are sometimes more reactions, right? Maybe more soreness at the point that you get vaccinated, maybe more likely to cause a fever. And so we've also developed what's called an inactivated vaccine. And this tends to have less what we call reactogenicity, right? Those side effects that can be uncomfortable. But because we're being a little more gentle with our immune systems, we often have to give booster doses. We also have toxoid vaccines. So many pathogens have nasty tricks that make it harder for your immune system to fight them. Tetanus and botulism produce toxins that are some of the most deadly substances on Earth. These are both bacteria. These bacterial toxins are sub-immunogenic, which means your immune system doesn't really realize that they're there. And so you and your immune system are pretty helpless against them. So by developing these vaccines, we can give your body, again, that head start. So if you are exposed to these pathogens and their toxins, you can fight them off really, really well. Many people were really understandably concerned about the newer mRNA vaccines, but they're not as new as people thought. There's actually been research going on for at least 10 years, and they had been tested in humans for other kinds of diseases before COVID came onto the scene. We also have some vectored vaccines, which again, they're about precision. They're about all the things that we've learned over many, many decades about the immune system and about different kinds of pathogens. And we've become really good at being able to make a very precise type of vaccine that's very safe and also really does the job it needs to do. So I wanted to give you a little bit of an analogy. All right, so here we see a picture of a 1970 Honda Civic, which is a great, reliable car. Honda Civics are great cars. It will, if this is all you have, it will get you absolutely to where you need to go. Very reliable. But what if instead of this 1970 Honda Civic, I offered you a 2021 luxury Tesla? Would you still want the 1970 Honda? You know, we drive around in new cars all the time and we feel safe. Why? Because they've been tested extensively and the technology, comfort, and safety are constantly being improved. And the same is true for vaccines. So try not to be too scared if something is new. It doesn't necessarily mean it's not going to be really safe. Vaccines are given to healthy people and they undergo much higher, more rigorous standards than anything else we put in our bodies. So let's move on to the sad story that we've all been living through, and that's the story of the virus SARS-CoV-2. This is an excerpt from a paper I remember reading in January 2020, very naively being a little concerned, but not realizing just how much this was going to upend the lives of every single person on the planet. There is reason to feel hopeful, right? We've been able to develop globally several different vaccines. And when you start reading some of this data, this is from Our World in Data, which is a great site to get information about, and data obviously, about the coronavirus and COVID-19 disease. You know, and you read this and you see, okay, 40% of the world's population has received 1 dose of COVID vaccine, and 5.2 billion doses have been administered, and 31 million are administered each day. And then you look and you see, less than 2% of people in low-income countries have received at least 1 dose, right? So again, we have some work to do. When you look at this particular map, right, share of the population fully vaccinated against COVID-19, this is a major, major problem. You know, I deeply appreciate being in a country where I have access to this and many other life-saving vaccines. But if we've learned anything from SARS-CoV-2, we're all interconnected as human beings, and we depend upon each other in many ways. Many of us in developed countries need to continue to push our governments to share more vaccines with developing countries, and this is essential to bringing the virus under control. There are a few things that I say with certainty about this crazy virus, but one is that it's not going away. It's in too many places, in too many people, and people can spread it before they know they're even sick or infected. We have to learn how to live with this virus, and we can only do this if we stick together globally and help each other. So speaking of sticking together and helping each other, I'm going to hand things off to 2 of my awesome students who are going to talk about the journal club that we worked on last spring to help each other understand the evolving science around this virus. So Leea and Henning, take it away.
Hi everyone, my name is Leea and I am a 3rd year here at MCPHS in the Medical Molecular Bio program. And for our project that we did for our journal club last semester, we were actually able to take information every single week from some of these amazing organizations that you see on the screen. For me personally, I took information from the World Health Organization and I reported on it every single week. And so it was really great because we had 5 students all reporting from these great sites and great data sharers, and we were able to talk about what we were finding. For me, I reported on the WHO's weekly epidemiology update, and so I was able to look at graphs and really determine what those graphs were showing. Some of my other peers, they reported on the CDC, as well as the New England Journal of Medicine, 2 really great places for information. And we were able to have these really great discussions talking about what was going on that week in the world of COVID, just looking at vaccine hesitancy and how we could combat that. So we really did a lot of work together and really trying to understand different things that were happening in the world. I really loved hearing about things. I learned so much every single week. And by talking with Dr. Hart about all the things that we brought to the table, we were able to have really great facilitated discussions around the information we were sharing, as well as really thinking about why things were happening and how we could share this in a really great way, which Henning will be talking about in a little bit. But Henning, is there anything else that you'd like to add about our journal club?
No, I think you covered it perfectly. So just to introduce myself in advance, my name is Henning Anderson. I'm also a 3rd year in the Medical Molecular Biology program. And I was the person that reported on the CDC's weekly morbidity and mortality report. And I had a very similar experience to Leea. Like, we learned so much, and it was very great to see a lot of information in a concise location and just chat about it for an hour and kind of like combat like the misinformation or anything else that we are hearing, especially as students and full-time students at that in person.
Great, thank you so much for sharing that. You know, this is really the inspiration for this was, you know, something that I've learned over many years being a scientist, and that's, you know, science, good science is a team sport. And so, it's really bringing together multiple reliable sources of information and going as close to the source of science, directly to scientists, that really helps to, to get at the truth in science. All right. So moving on. So our journal club discussed, right, the science of SARS-CoV-2, and we looked for inspiration to help us explain science to our friends and family. And one example is that we came up with is this soup analogy. So mRNA vaccines, at least from my perspective, have relatively simple ingredients. There are a little bit of instructions, right, to make the virus, and part of the virus, I should say, that's protected in a little lipid bubble. So because it has relatively simple ingredients, I'm kind of making the analogy that mRNA vaccines are like chicken broth. But there are other types of vaccines, some with similar ingredients and some that have extra ingredients. So, I kind of gave them a little bit of, a similar base, right? They're all chicken soup, but some have vegetables and some have noodles. So some soups taste good to me, just like some vaccines taste good to my immune system. But sometimes our immune systems don't like the taste of certain vaccines, which is where allergies and rare reactions can come in. For some vaccines, may be better or less reactogenic, right? Again, that term that has to do with reacting in some way could be something mild, like, feeling sore in your arm or getting a fever, could be something more serious. And, for some people, there might be some vaccines that are going to taste better to their immune system, less likely to have an allergy or a reaction. And for others, it may be a different type of a vaccine that might taste better to their immune system. Another way of looking at this, my husband and my son both happen to be allergic to penicillin, but they're not allergic to all antibiotics. Just because they're allergic to penicillin doesn't mean they don't take another kind of antibiotic when they're sick. So if you have concerns, and I think that's very, very reasonable to have concerns about myocarditis or blood clots. By the way, your risk of myocarditis and blood clots if you get infected with the virus is much, much higher than those risks from the vaccines. But if you do have those kinds of concerns, then maybe a different vaccine would be better for you. Not everyone has the luxury, of course, of choosing which vaccine, though, as we saw in previous slides. We still have a long way to go in terms of vaccine equity. But I will tell you from my own personal experience, back in May, any of the vaccines that I'd seen the data on that were approved in the United States, it's called an emergency use authorization, or EUA. I would have taken any of those vaccines that were given to me after, what we had been going through for so long, over the course of 2020 and then the beginning part of this year. Here's a different analogy to help us understand how the immune system works. So antibodies and B cells that make the antibodies are part of our first line of defense against infection. It's normal for the amount of antibodies to go down after vaccination over time. This isn't something new for COVID vaccines. If our bodies cranked out high levels of antibodies for everything we've ever been exposed to or vaccinated against, our bodies would be clogged with those antibodies. We'd be a walking antibody. This is why our B cells are around to keep the memory of those exposures. And then they ramp up the production of antibody quickly when we actually need it. Again, that race analogy. So it's not unexpected or unusual for vaccinated people to get infected with SARS-CoV-2 and even get some mild symptoms. Over time, it will take a little bit longer for those B cells to crank up antibody production. And this gives the virus a little bit more of a chance to make more of itself and make you feel some symptoms. But remember, we are still at a big, big advantage in this race if we are vaccinated. So B cells and antibodies are a bit like the Navy and its torpedoes. They try to get the floating bad guys, the viruses, before they reach land, your cells. When antibody levels go down, a few bad guys might make it into your cells and you might start to feel sick. But those memory B cells will still do a great job keeping the infection in check. Also, we have a whole different branch of our immune system called T cells. T cells are like your army. If the bad guys do land, if they make it past the Navy and they do end up landing or entering your cells, T cells will help destroy those infected cells and lessen the impact of the bad guys, prevent you from hospitalization and death. So far, the vaccine doses that people have gotten are highly, highly effective against hospitalization and death for the great majority of us, against all variants we have come across so far, including Delta. When talking about things that you put in or do to your body, it's important, of course, to think about risk versus benefit and balancing those things. Remember that anything in our environment has risks associated with it. OTC or over-the-counter medicines like aspirin have some risks associated with them. Aspirin in small children in certain circumstances can cause a very rare but serious side effect called Reye's syndrome. Prescription medicines, of course, if you've read the instructions and the little packaging associated with prescription medicine, often there's lots of different things they warn you about. I love to eat out. I don't like to cook, but eating out has risks. You're trusting someone else to wash their hands after they go to the bathroom and cook your food properly. Foodborne illness is a major cause of illness and even death globally. Unfortunately, there's a lot of things we do to our environment that is not good for our health. We do things that pollute the air we breathe or the water we drink. Clearly, that's not going to stop us from continuing to breathe and drink, right? So again, a good way to frame the discussion of vaccines is to really weigh benefit and risk. Going back to the car analogy, right? There's a very high rate potentially of getting hurt in a car accident when you get into a car, especially here in Boston. Not great drivers in Boston. But most of us, right, still get in a car because the benefit getting to where we need to go outweighs the risk of potentially getting in a car accident and getting injured. Even though my kids are at low risk of dying from SARS-CoV-2, they're not at no risk. And long COVID is a real phenomenon that we're only beginning to understand. So we're going to talk now a little bit about my son's story. People sometimes forget that scientists are moms and dads too. This is a picture of my baby, my son, from a long ago. Isn't he cute? Basically, these days, he talks down for me from above because he's 6 feet tall and he has a deep voice. But he was very cute back then. And basically, you know, when I found out that last November that there were very safe vaccines that worked really, really well, I knew that vaccine hesitancy was going to be an issue. So I decided to use my expertise. I have a PhD in microbial genetics from the University of Paris. And I decided to use that to help my friends and family on Facebook try to understand the science so they could make positive, informed decisions regarding their health. So I started to create these Facebook posts that then morphed into these types of Instagram projects that Henning's going to talk about in a moment. And just to show you this one, you know, I basically was sharing that, you know, I was very happy when my little guy was little and I could protect him from polio, measles, or meningitis. Of course, I was less successful at protecting him from spaghetti sauce and yogurt that's plastered all over his face. Fast forward, right? My son's now 18. Here's him playing hockey and scuba diving and fencing. And this is a picture of him getting his first dose of the Pfizer vaccine. And I wanted to share that story again, right? Because stories are important. And it's important for people to hopefully realize, right, that we scientists want to do what's best for all kids, including our own. So to talk a little bit more about this Instagram project, I'm going to pass it back to Henning and Leea.
Awesome, thank you. So in addition to the collaborative journal club, which Leea talked about, where we reported on all these reputable sources, another big part of our work was obviously with the social media awareness regarding vaccines and vaccine hesitancy. So Dr. Hart definitely did a great introduction about her Facebook group, which I'd implore any viewer to join because she pumps up some amazing content and very relevant content in that. However, as Generation Z students, we wanted to bring awareness into different social media platforms, and thus our Dr. Biology Mom Instagram was made. So during the course of the 4-month time span, which Leea mentioned, we worked to convert some of Dr. Hart's Facebook groups into simple and concise infographics, and then we posted them onto Instagram to reach this separate audience and those demographics of those individuals who use Instagram way more than Facebook, such as myself, and I know Leea as well. And obviously these infographics did come out great, if I do say so myself. And we used Canva, which is a graphic design platform, in addition to cartoon caricatures of ourselves, which were made with Bitmoji. And I have a few featured right there of Leea, myself, and Dr. Hart. And they were very, very fun and easy to understand for readers of any age or educational level wanting to learn about COVID-19 or vaccines. So I think it's a very great platform to reach a whole bunch of different people. This Instagram project, along with Dr. Hart's Facebook group, will continue, and we're also looking for different ways to reach other audiences, such as converting our infographics into different languages, which is a brand new idea that we just started thinking about and talking about how to implement that going forward. So I definitely drop a follow onto our Instagram using that @ that's on the screen right there. And maybe if you want to repost something, you can use some of those hashtags that we have there as well.
Thanks, Henning. 69 followers. I know it's not very impressive, but but we've been working hard, and the point for us really, is to learn and to try to help, do what we can. As I mentioned before, the best science is done together in a group. I have a lot of my biology professor friends on Facebook to help make sure that I'm giving accurate information. Towards the end of this talk, I'm going to share a few of my favorite teams, science teams, that I get my information from that I really highly recommend. All right, so I wanted to kind of wrap up this talk talking about something very, very important, which is human behavior. I have some amazing colleagues here in our psychology department. I look to them a lot for advice and knowledge. And I've been learning a lot about some really interesting things that contribute to the really complex issue of vaccine hesitancy. It's very reasonable for people to have concerns and questions. And nobody should ever be shamed to have those kinds of questions and need to get them addressed before they feel comfortable getting vaccinated. But there are a couple of things that can interfere with our ability to make decisions that are good for our health. Confirmation bias is one of those things. It's an aspect of human behavior where we like to look at things that make us feel good, and we don't like to look at things that make us not feel good, which is natural, right? Unfortunately, this is something that social media can take advantage of, right? They have algorithms that when you like something or you watch a certain video, they're collecting data and they feed you more of the things that make you feel good, right? The things that you like or that you stop up on various social media platforms. And I think we have to be a little careful about this. I've been really trying lately to be a little bit more, push myself, to make sure that I'm seeing a broad range of perspectives from reliable people whose credentials I know and can, feel a little bit more trusting of. There's another concept related to human psychology called complexity bias. And this is something that is discussed often in medicine. When doctors are being trained, there's a little saying, when you hear hooves, think horse, not zebra. And basically the idea is if you walk in, if a patient walks into your emergency room in Boston with really serious flu-like symptoms, don't immediately assume they have Ebola, right? We tend to overcomplicate things. Probably why, we do tend to like maybe conspiracy theories, why lab leaks make newspaper headlines, but the much more likely spillover of a virus from animals doesn't make those headlines. Complexity bias is a thing. There's also something called omission bias, and as a tendency we have as human beings. And the way that I like to describe this is that even though doing nothing, right, being passive can be really risky in certain situations, it often feels better for us to be passive than to be active, even though taking action is less risky. Okay, that sounded like a mouthful. Let me explain that in terms of vaccination, right? A lot of times people feel very hesitant, right? Even though not getting vaccinated is more risky than getting vaccinated, right? In terms of your chances of getting very seriously ill, hospitalized, or dying, it's hard to get over that hurdle. Taking action to do something less risky is harder than not taking action when the situation consequences are even riskier. Hopefully that made sense. But, often scientists, we make the mistake that just because we love facts and data and tables and graphs and figures, right? We think if we just give that out to people, they'll decide to do what we want them to do and get vaccinated. But that's basically called the knowledge deficit model. That's not really going to help in a lot of situations to convince people. Vaccine hesitancy has a lot to do with trust. And there are some populations, at least in the United States, that have very valid reasons not to trust medical professionals or scientists because of historical or even current lived experiences. Taking action for our health is often tied up in cultural beliefs, personal values, our sense of identity, with politics sometimes sprinkled in. So it's really important not to judge people, to really listen, to share stories again, and to really be patient as people try to figure out what the right thing to do is for their health. So here are some of my favorite storytellers. Again, what I tend to gravitate to, because I feel like this is where the best science happens, is groups of scientists from respected institutions who have dialogues to get at the truth, to look through data and discuss it, and try to come up with some sort of consensus after not just one preprint, right, is released into the media, but after hopefully several kinds of studies and accumulation of evidence happens. So in the top left is my favorite virology podcast. This is run by Vincent Racaniello, who's a professor of virology at Columbia University, just to the south in New York City. And he has a really great team of really lovely people. And they do a fantastic job explaining some pretty tough science. And they have really awesome guests too, people who have so much insight to share. Again, I like to go as close to the source of science as possible to really get, good science. On the right, this is the University of California, San Francisco Department of Medicine. They have Grand Rounds. This is on YouTube. And they have a really nice mix of doctors and scientists. And they talk about a lot of important topics, again, together, where they can bounce ideas and share opinions with one another. And then lastly, in the lower left corner, again, one of my really favorite sources, Storytellers, is the American Public Health Association, or APHA. They've been doing this series called the COVID-19 Conversations with the United States National Academy of Medicine. And they've been really wonderful at exploring, again, some of these really crucial issues, not just the science and the medicine, but public health, global equity, and really trying to help with health disparities, which exist here in the United States and obviously all over the world. I have a couple of recommended stories. So if you're interested in trying to understand a little bit more about vaccine hesitancy, there are two different books that I highly recommend. They're really good reads. One is The Panic Virus by Seth Nunkin, and the other is Stuck by Heidi Larson. She's a professor of epidemiology at the London School of Hygiene and Tropical Medicine and one of my heroes. If you want to know a little bit more about the spillover of microbes into humans, here are two really fantastic, well-researched sources. One is actually released a long time ago, but still very, very interesting and helpful to read today, and that's The Coming Plague by Laurie Garrett. And then David Quammen's Spillover is also a really, really good read. All right, so with that, I will stop screen sharing so I can see people's lovely faces. And yeah, I guess if there's any questions, we're happy to do our best to try to answer them.
Well, thank you very much, all of you, for a great insight into this. I think it's something that we've all been battling with a little bit over, the Corona period, but it's nice that you've put so much effort into kind of researching it. And I guess one of the questions I have is, in all your research, have you found a good way of kind of combining the scientific literature, the way vaccines work with the analogies, and then also with these psychological biases? Have you found any kind of formula or sequence or way of kind of combining those to actually have a good productive conversation with people who are hesitant about vaccines?
Yeah, that's a great question. I think it's a process that we're constantly learning. My training is in bacterial proteomics, but being a mom again, I love to share science with my kids, and I have two kids here. Sorry, young adults, I should say. I tend to think of my students as my kids. My kids are my genetically related kids, are also young adults, but basically really trying to learn how to be a good communicator. That takes time. As you mentioned, integrating an understanding of psychology. And I mean, it's really fascinating to explore the intersection of public health and genetics and microbiology and psychology. I'm a big believer that there's always something to learn from other disciplines. I've done some collaborations with professors in the field of ethics. And yeah, I think having an open mind and trying to learn as much as you can from different disciplines, and then just, doing your best to really, work to integrate those things together in discussion, right, with students or colleagues.
Yeah.
Do you guys want to add, Henning or Leea, do you want to add anything else to that?
I think that by having the conversations and being in programs like Henning and I are in, we have a really great understanding of how it works at a small level. And so being able to kind of build on that, and by looking at the science from reputable sources, and then also having conversations with professionals who are in the field, I think that really helps, because for me, for example, I've studied biology for the last 4 or 5 years in high school and now in college. I feel like I know a lot, but there's so many other people that know a lot more than I do. And so I learn from them. And by hearing the different analogies and the stories that Dr. Hart has shared, I think that it kind of puts the pieces together so that you can have a story too and kind of understand how it works. And so I've personally had a lot of conversations with people close to me about vaccines and how important they are and how safe they are, because I've been able to have conversations with Henning and Dr. Hart in our journal group. We discuss so much. And I feel like in those situations and circumstances, it really helps you to make a formulated decision and helping share the wealth of information in a productive way.
And this is honestly, my goal is not to become social media famous at all. I'm a very private person. You know, I just want to help, you know, and obviously it started with just my friends and my family, really trying to reach out to them. But, you know, I also really want to help my students become, you know, better ambassadors for science and health. And, you know, and so this has been a really rewarding project to be able to help inspire young people, right, to really know where to go for accurate information, how to put it all together, and how to communicate it to keep their friends and family safe.
Yeah, so kind of just piggybacking off both of those, I'm probably one of those young people who would most likely benefit from that. At this point in my life, I have an attention span of like a goldfish. So using like the infographics that we've developed, I think is definitely like the best way that I absorb information. And even though we're only 69 followers strong, as Dr. Hart pointed out, which hopefully will change after this, little shout out to the audience. But like just reposting those and allowing my friends to see them as well definitely gets the information out, because the amount of time that I would spend on social media compared to reading the morbidity and mortality weekly report is astronomically different. And seeing that accurate information all in one place while I'm just scrolling through my feed, I think is very beneficial.
And we try to be really, really careful, again, because we're using a lot of different sources. We're trying to be really careful to not share anything, you know, that's, or, you know, or to say when we're not certain, right? To be honest and transparent when we're not sure about something, when we don't have enough evidence yet. And when we do, you know, we get excited about that and we want to share that too.
Great. Yeah, I hope we get some more followers on there after this. Yeah, definitely reach out to us on you did mention Twitter. I'm on Twitter at the moment. I could give you a shout out, but on Facebook and Instagram, maybe we can do it later on.
Yeah, we were going to try Twitter, but yeah, I mean, last year for all of us, right? It was a rough year work and study wise for students and teachers all around the world. So, you know, Instagram was about as much as we could manage. Yeah. I'm a little scared of Twitter, to be honest, but I'll try to keep an open mind. Actually, we might do TikTok. Actually, we're cooking up some ideas with TikTok.
Okay, TikTok.
Don't tell my genetically related kids. The first time I tried TikTok and posted a video, I was lip syncing to Lizzo, and they were so embarrassed.
That's what TikTok's for, I think, isn't it? I mean, it's for.
Exactly.
We're embarrassed too.
Yeah, everyone's embarrassed on TikTok and they don't care. I think that's the beauty of it. Okay, okay. Let's just agree to meet on TikTok then, and we'll embarrass each other there. I have another question for you about your background and when you're talking about this kind of stuff, because at the beginning, kind of noticed you were careful to say that you're not affiliated with any companies or anything. So. Does your background have a positive or negative effect when you're talking to people? Do people say, well, of course you're going to be pro-vaccine because of where you come from? You're probably like a pharma company shill, and you kind of you're taking, does it have a positive or a negative effect when you're talking to people?
Yeah, I mean, I think it is really important to disclose, whether you do have that kind of affiliation. It doesn't negate what you're saying, but it's important to be really honest and upfront with people. For me, I always try to approach it. I mean, it's important for people to have some expertise, right? I mean, I can tell you my PhD is in microbial genetics is super helpful during the past, year and a half, as I've tried to navigate a lot of things that often, even to me, are very confusing. And so figuring out, right, again, who was I going to listen to and how I was going to try to, bring together that information. We talk a lot in public health about the importance of trusted messengers. And so again, there are a lot of people on social media, some very well-meaning, but often it can be about egos, right? And that's again why I like groups of people, groups of scientists that talk together. I mean, for me, I think I'm really good. My friends, my family, the people who know me on social media, I'm probably a good person to reach out to them. They trust me, right? We have a relationship, but, you know, for Leea's friends and family or Henning's friends and family, right, they're the trusted messenger, right? They're the people who are really going to be able to, you know, to help people understand as they're developing their expertise, right? And as a teacher, I, you know, want to help them to know how to plug into those sources. So does that answer your question, or?
Yeah. I think that's really valid. I think I've seen it as well. You know, you need, whenever you're communicating about things like this, especially with someone who you think or is likely to disagree with you fundamentally, then you have to definitely have that element of trust to start the conversation, which is even more difficult to develop online, right? Do you have any tips or advice for how to be a trusted messenger online?
Oh, yeah. You know, honestly, I agonized for a little while before I started, you know, I created the Biology Mom group on Facebook last November. I agonized. I'm like, you know, do I really want to add my voice to all the craziness that's out there on social media? You know, and then I realized, you know, I have this expertise. I care. I want to make the world a better place. I want to end this as fast as I can, you know, as we all, you know, pitch together. And also, if I didn't speak up, then I'm letting people, and there are people, a lot of people out there actually, who are purposefully putting out misinformation because they profit from that. And so, you know, if I don't say anything, I'm letting those people dominate the conversation. So yeah, I mean, I think it's really hard on social media, and each type of social media platform has its own flavor, right? To go back to the kind of soup analogy. Again, I just hear scary things about Twitter. I don't know why. I don't know why. It seems like a scary place. You know, but you know, I think on social media, as much as possible, if you can plug into sources where you can have a back and forth, like a dialogue, I think that could be helpful. If you plug into sources, again, that have, you know, they're clear about what their affiliations are, what their expertise is. I'm very wary of websites or social media where you don't know who's writing it. You don't know who's representing it. Be a little wary of egos, I would say too, on social media. Again, there's some very well-meaning people, and I watch some individuals on YouTube that do science education or health education, you know, but every once in a while I'm like, oh, they didn't get it right, because they're by themselves. Whereas in a group, you're much more likely to be able to, you know, work through your thinking and have misconceptions corrected, if that makes sense.
Yeah, it does. I think it makes a lot of sense. I think, I mean, it's good advice for everybody, but maybe that's also a way of kind of ending conversation with people when you don't agree. You say, look, this is the way we look for information. Like when you're looking at your own information, make sure that you do the same as I'm doing. Make sure you look for groups of people who are having discussions. Make sure you watch out for egos. Make sure you know, so that you actually encourage people to find out for themselves and kind of do the proper research, because it feels like that can be missing when you have the misinformation.
Yeah, I mean, so much has been sensationalized, and you know, there's some amazing journalists, and I really have a lot of respect for that field. I don't think it's an easy field at all. But at the same time, that's not where I want to get my scientific information. I want to get it from scientists. And yeah, I mean, for me, education is the key to everything. I grew up during the HIV epidemic in San Francisco, my hometown. And, you know, part of the reason I became a biologist is because of that. And I very quickly realized that actually, you know, science is great. I love it. But for that pandemic as well, education is really the key. So that's where I'm really passionate and try to help, again, empower my students to really become also, you know, engaged health educators, science educators, ambassadors.
Great. Education is the key. I think that's an excellent place to wrap up. And I'd just like to say, yeah, thank you very much to you, Janet. Thank you, Henning and Leea. It's been an absolute pleasure. And yeah, we'll move on to the next session, but I'll definitely look out for you on social media, and yeah, we should definitely meet up on TikTok when we get our accounts started, and yeah, that's going to be fun. So thank you very much for today, and
thank you for inviting us.
Thank you so much.
No problem. Bye now.